Hey everybody, thanks for watching another math video. This one is about simplifying radicals. It's a little number trick that I want to show you. You'll find it very useful for a lot of math problems, okay? But let's first get our terminology straight. A radical is the symbol that we use to mean a square root of a number, but it could mean other roots as well. Something like, the square root of 5, square root of 16, 3 times the square root of 2. Sometimes people would say 3 radical 2 even. It might be a different root also, like the cube root of 8, or the 4th root of 5x, or the 12th root of 2, which is actually my favorite number. Anyway, simplifying a radical means that you want to write it with the smallest number as possible, as small a number as possible inside the radical. All right, that's what it means to simplify a radical, is to rewrite it with smaller numbers. Okay, so let's, for an example, let's say we're going to simplify the square root of 12. Well, 12 is already not very big, but let's see if we can make it smaller. So here's how we're going to do this. Oh, by the way, that number underneath the radical, it's called the radicand. I might use that term a couple of times in this video here. So not very often that we use that word, but that's what it's called anyway. All right, so the trick that we're going to use here is we're going to try to find factors of 12, all right? And we want to find a factor of 12 that is a perfect square. And if you're not sure what I mean by that, just keep watching. I think you'll pick it up. All right, so the factors of 12 are 1, 2, 3, 4, 6, and 12, and 4 is the only perfect square factor of 12, okay? In fact, 4 times 3 equals 12. So that means then the square root of 12 is the same thing as the square root of 4 times 3, because 4 times 3 equals 12. Well, this you may not be aware of, but you can take that square root of 4 times 3 and break it up into two radicals. All right, square root of 4 times the square root of 3. Now, if you didn't know that you could do that, well, now you do. And this is really one of the keys to simplifying radicals, is to break them up into products of radicals like that. So the square root of 4 equals 2. That means I can replace the square root of 4 with 2, which means the square root of 12 equals 2 times the square root of 3. And that's simplified. All right, that's what we mean by simplifying a radical. All right, so the process really is to rewrite the radical, or actually rewrite the radicand as a product of two numbers, one of which is a perfect square. All right, just in case you're not sure, perfect squares are numbers like this. They're like 1, 4, 9, 16, 25. Any number times itself gives you a number that is a perfect square. So 6 times 6 is 36, 7 times 7 is 49, 81, 100. You can keep going. So you're trying to rewrite the radicand as a product of two numbers, one of which comes from that list that you're seeing right there of perfect squares. All right, let's try this again. Let's say we're going to try to simplify the square root of 20. And remember, there's our little process there. Rewrite the radical as a product of two numbers, one of which is a perfect square. Well, like 2 times 10, except 2 times 10 doesn't use a perfect square. Neither 2 nor 10 are perfect squares. Well, what about 4 times 5 then? Yeah, that works, because 4 is a perfect square. All right, so then that means the square root of 20 is the square root of 4 times the square root of 5. All right? Make sure that you see that connection right there. Right there, that's a very important little step. That first step of breaking up the radicand into two radicals there. All right, the square root of 4 times the square root of 5. Square root of 4 can be simplified down to 2. The square root of 5 does not simplify, so we leave it alone. So there you go. There it is, 2 root 5. That's square root of 20, simplified. Let's try another one. Let's try the square root of 8. This one's a good one. I hope you watch this one. Well, okay, 8 is 4 times 2. So that's, again, a perfect square of 4 there. So that simplifies down to 2 root 2. All right? Okay, so there's a couple of examples here to start you off. Why don't you, after you see these here, why don't you try to pause the video a little bit and see if you can come up with the simplified version of each one of those radicals. Square root of 18, square root of 72, square root of 27, and the square root of 50. All right? Okay, well, if you gave that a try there, I hope you paused the video for a second and gave it a try. Let's see what you got. Okay, the square root of 18 that's 9 times 2, right? Square root of 9 is 3, so that equals 3 root 2. Did you get that? Good. That's good. It's 3 root 2. Square root of 72, well, that's 36 times 2. 72 is 36 times 2. So the square root of 36 is 6. So that just gives me 6 times the square root of 2. All right, and I'm putting a little asterisk there because I'm going to come back to this one a little bit later on in this video, because you might not have thought of 36 times 2. You might have tried something else. And I want to talk about that a little bit with you, okay? But the square root of 27, that's 9 times 3, so that gives you 3 times the square root of 3. That's good. And the square root of 50 is 25 times 2. 25 is a perfect square, so the square root of that is 5, so that's 5 times the square root of 2. All right, so there's our simplified versions of all of those radicals. There are advantages to being able to do this, and you will see these advantages as we progress through our course, and you will get a lot of mileage out of this skill in all your future math classes, I bet. All right, let's try 4 more. So try pausing the video one more time to practice, see what you get when you simplify each of these. Alrighty, well, I did kind of throw you a curveball there. The square root of 100, well, 100 is a perfect square, so that's just 10. It didn't really use this trick, but I just hope you get in the habit of always writing the square root of a perfect square. Write it as just the number. Don't leave it as a radical if there's any reason, to do that. Okay, what about the square root of 24? That's 4 times 6. That gives you 2 times the square root of 6. Notice the square root of 4 becomes 2, but the square root of 6 just stays the square root of 6. Does not change. All right? So pay attention to which numbers stay inside the radical when you're done with this. All right? And you can always verify this on a calculator. You can always just check and see if what you got really is the same thing that you started with. What about 30? Square root of 30, you could try 3 times 10 or 15 times 2, but those aren't perfect squares, so you wouldn't use those. What about 6 times 5? Nope, neither one of those numbers are perfect squares. This means that the square root of 30 cannot be simplified. 30 has no factors that are perfect squares, okay? You will not find a factor of 30 from that list of perfect squares that we saw a second ago, all right? Well, what about 54? 54 is 9 times 6, so you got to remember those dusty corners of your times tables. All right, really helpful here. But that gives you 3 times the square root of 6, and those are all the simplified versions of that. Okay, well, that's quite a bit of practice, but I want to come back to this number, square root of 72. It's kind of an important point to make about this. So what we did was we said that's 36 times 2, which simplified down to 6 root 2. But 72 has other pairs of numbers that multiply, right? 36 times 2, 24 times 3, 18 times 4, 12 times 6, and 9 times 8. Now, what makes this even more confusing is that 3 of those pairs of factors have perfect square factors. So 72 is kind of tricky in this regard. Now, so what would happen if you tried 18 times 4? Okay? So square root of 72 is the square root of 4 times the square root of 18. That gives you 2 times the square root of 18. Well, that's not incorrect, but it's just not simplified all the way down, because 18 actually has a perfect square factor itself. 18 is 9 times 2, and so the square root of 18 is the square root of 9 times the square root of 2, which gives you 3 times the square root of 2. That means I could replace that. You see 2 times the square root of 18 right there. I can replace the square root of 18 with 3 times the square root of 2. And so 2 times 3 times the square root of 2 gives me 6 root 2. Same thing that I got the first time, all right? Well, what about 9 times 8? Because chances are good that that's the one that you tried. And it seems like a really good choice. 9 times 8, the square root of 9 is 3, so you get 3 times the square root of 8. That looks pretty good, all right? However, 8 has a perfect square factor. It's 4 times 2. So the square root of 8, as we saw earlier, simplifies down to 2 root 2. So I can replace the square root of 8 with 2 root 2, and I have 3 times 2 root 2, which is 6 root 2. So I still get the same thing, of course. All right? But it took us a lot longer to get there, right? There's a lot more work, a lot more confusing, a lot more places to make silly, little mistakes. So my pro tip here that I'm going to leave you with finally is this. Whenever you're doing this process, try to find the largest perfect square factor that you can, all right? Now, you might not find the largest one at first. So keep on going. Don't give up, all right? Because the largest perfect square factor might not be obvious to you. So keep on working. Don't write any radical if there's a factor of that radical that is a perfect square. And that's how you simplify a radical all the way down. Okay, hey, thanks very much for watching. You guys are awesome to keep watching all these math videos. I really, really appreciate it. I hope you're doing well, and stay safe, stay smart, and do some good math out there, okay? All right, see you soon. Bye-bye.